Let's take a look at the circuit. For this simulation, we are using an Arduino UNO R3 as our central microcontroller, while our final build is designed for an ESP32. We have chosen the UNO R3 as our primary simulation replacement because it is an industry standard for prototyping, and it is also offering a highly stable 5-volt logical environment which make it perfect for validation of our analog to digital sensor module. For our primary input, we have our soil moisture sensor. This sensor works by measuring the volumetric water content of the soil by evaluating the electrical resistance between its two conductive probes. So as the soil varies, out the resistance increase, which change the input voltage signal sent to our Arduino. The Arduino has a built-in 10-bit analog to digital converter which takes the income voltage from the sensor to a pin A1 and maps it to a digital between 0 to 1023. We then use this resulting digital values in our output module, which is actually the best part of the design. A lot of standard plant monitors just give you an output as simple wet and dry B. But if you are really taking care of that of your plant, like a tulsi plant that's sitting out on a sunny balcony in Dubai or anywhere in the world, waiting until the soil is completely bone dry, is usually too late. So you are really want to know when it is almost getting dry, so that you can be proactive. So instead of just one alarm, we have implemented 5 LEDs over here, which are blue, green, yellow, orange and red, which give the user the real time visual idea of the plant's health. And just in case you have missed a light, we have also added a piece of buzzer on the pin tree, which act as our absolute last resort alarm, and it only goes off if the soil is in the critical red state and desperately need water.